It's actually a little bit late for me. I normally like to start work about 6ish, but I had a bit of a lie-in this morning. We've actually got a brand new RePCB here. So we've got obviously the two ASICs here. So this is the one that's been selling for a few weeks now, really popular. But the 2 ASIC is much less popular in, I think, like America. Like Europe seems to be mostly 2 ASICs, but we've had a lot of requests for supporting this 1 ASIC here, basically. So we're going to open this up. I've literally not opened it yet. So this is from the factory, the samples I've obviously designed, and this is the first prototype. It's partially assembled. So let's take a look at this. And if I haven't made any mistakes, which is unlikely, to be honest, it's normally you'll make a few mistakes on your first run. But if I haven't, then this will be a working board straight away. Nice. So there's the new board. Obviously looks very similar. The quality on the silk screen is not as good, so I'll have to mention that to them. But this might be because it's a rapid prototype, so the quality of like the print might be the reason for that. So let's just inspect this first closely to make sure we can't see any issues. I've also now got, looks a bit laggy actually. A little bit laggy maybe. I've got a new overhead cam now. I forgot I'd got the Blackmagic cam, so I've now got zoom control, obviously where I had it. We can zoom in and out. And I've got, at the minute, the workaround is to use an app on the phone through Bluetooth until I make some Bluetooth setting, and I can just tap now to focus. So we don't have to keep reaching up and grabbing the camera and stuff. We have focus. But let me just check if the frame rate's set right. It just looks a bit, slight bit laggy. Let me just disable and re-enable that video feed a minute. Is that froze? Yeah, there we go. Now reactivate. That's better. Looks it's. I think it's just because it's 30 frames streaming, isn't it? Not 60. That's probably what it is, to be honest. It's before I go live, it's 60 frames a second. And I think when I stream, it goes 30. So we have this obviously new one. All I want to do is look around here. You can see obviously like this. I think this has just been printed on a conventional printer with it being a rapid prototype, but that obviously is nowhere near as good as the mass production print. So look how nice and dark and black that is, and that's like fadey and grey. So that's obviously minor point, but we do need to mention that to the factory to make sure, because this is a sample, that it's going to not end up looking like that. We have now this switch I'm not 100% sure on, the 50-60 Hertz switch, because it's a little bit flimsy as well. Mine just got no support underneath, so I think that's by design. On the schematics, on the scan schematics, to me the 50 and 60 Hertz wasn't 100% certain, because we have an NTSC. I think on the schematic it was a NOT JAP or an NTSC, and then we also had a PAL switch, which doesn't make sense because it's either PAL or NTSC in a sense, and it's 50 or 60 Hertz. So my guess is this will be a 50-60 Hertz switch, and this will be just purely a language switch for games that want to recognize region. So we'll see when this starts, if it works, if I've got them right, and if they're the right way around. USB port's the same design. Backlight hasn't changed. You'll see there's literally nothing here now because the one ASIC takes care of it. These shouldn't be any different because they're pretty much a copy and paste of the last design. This was the heavily convoluted area to fit all 3 chips in one place. The only thing to watch out for is obviously these 2 resistors. Due to how tight the traces are, I couldn't really move them much further away because all these are sound. So all this, oh, we're missing a component there as well. I'll double check that should be on. See if we've got another sample. All these are basically sound, so you have to keep the sound away from everything else. So the sound comes up through this big wide gap here. So you see the big empty trace. The sound comes up the other side, I believe. See, so it goes over there, and we keep that free for sound traces running. So you see them running between with enough gap so that it doesn't interfere, and then the sound trace is guarded all the way up. So if I can remember rightly, I think it's these 4 traces here that run down, and there's like ground vias either side and plenty of gap. And it's just it's basically to make sure you don't get interference on audio. So because of that, and this taking up a lot of this area, and we're having to go through here and up there, these really had to be located here. Otherwise, I'd naturally move them so you don't knock them. But what I'll probably do is provide the details for, the close caps and resistors in case you knock them off. Then you can obviously replace them. Let's just see if this one's got it on. Yeah, this one's got it on, so let's just move that board out of the way. No point in replacing one for now, and we'll use this one. Just zoom in a little bit. Or are we maxed in zoom there? Right, we're maxed in zoom, so let's go to the digital zoom. Of some 90s consoles, all work fine. Do you think it's worth proactive recaps? 90s is probably coming on the verge of wanting a recap, but it all depends on the consoles. If you feel confident that you're going to recap it without doing damage, I would. If you're not confident, I probably wouldn't at the minute, because a lot of people damage things by recapping versus, if they're not skilled enough, just leave it where it is for now or send it off to get recapped. I wouldn't do it if you don't have experience in already doing it on an existing working console, because you've got much more chances of basically damaging it. So all these soldering points look good to me. We've obviously got put the clock on, but with this being a new board, I'm just double checking the rest. So I think visually, other than that one missing one cap, I don't see any major issues here. And this is already pre-tinned again, just because it's factory. I'll just make sure this isn't tinned on the production one. So now I guess let's put on morning. Just notice the other chat. I'm not paying too much attention to the chat at the minute. We've just got a prototype, new prototype 1 ASIC in now for the Game Gear RePCB. So we can hopefully make use of all these as well. I've got tons of these. We've pretty much used up all the 2 ASICs I've got lying around. So hopefully this works first time. And the other problem is that this doesn't work. This just turns on and off. I'll show you why I've picked this as well. Like, my thought behind, obviously we don't know if these boards work yet, so we're as good as guessing if there's a problem, whether it's the ASIC or my actual board. But the reason I think this one works is when you turn it on and off, if you watch the red light, he says, well, it did before, now it doesn't. That's a shame. What I was getting was the red light flicking on, then going back off, which is normally a sign the ASIC's alive and doing something, but this one isn't even coming out of red light boot now. So we've got that many boards though. I think I'll just swap. I can't keep going through them. They're all obviously boards that don't work for a reason, so we can't really prove if the ASIC works. So we'll just have to hope for the best. But it might be a bit of a rough ride getting going at first until we figure out what's wrong. If we do get issues, it's going to be a bit more complicated for the first one until we know our design actually works, basically. So let's just chuck the crystal on. This will come on this version, so you won't have to assemble this crystal. This will literally come pre-installed. So that's another benefit for this. The only thing you'll have to do on the 1 ASIC is put the literal ASIC on. There's nothing else to do. Rotate that around. That way, I believe it is on this one. There we go. Let me just double check again, not that the polarity as such matters on this because it's a crystal, but let's see what I was doing on this. We were actually putting that on the other way around. So let's just for good measure flip it round, just so we're matching the two ASIC for now. Again, anything that helps prevent possible issues we want to do on this one. So we want to rotate him around. There we go. And I don't know whether I don't know if the factory could do this, but they probably could. This is already pre-tinned, and the fact that I pretty much always recommend... No, I won't actually. I was going to say I always recommend hot airing these on, but there will be people that want to hand solder, so we won't have these pre-tinned. I was going to say it saves yet another step if we just get this entire thing pre-tinned first, but we won't cut that step. We'll let people choose on that one. I think I need to update the LUT on the camera as well, the new colour mode. Looks a little bit foggy, slightly over curved probably on the highs, because I've had to try and match, obviously, the changing the camera, I've had to match the colours between the two. So now I guess the only other thing is the orientation. Did I forget to rotate this around? I think that writing is the wrong way around as well, because what I like to do is put the writing on here the same way as it's written on the chip, and I'm sure, if I remember rightly, this wasn't oriented upright. So I've got a feeling it was this way, like upside down, and the dot would be there. So let me just pull up the schematic to try and remember this. Just have to check one of the pins, and I'll pull up the actual design. Game gear. Right, so one ASIC has the sound, yeah, so the sound, oh, it is actually pointing up, I think. So if we look at, if I just pull up the screen, drag this over, what I'm looking at is on the one ASIC here, on the right side, see all these bright yellow pins, that's the sound. Welcome in from California, nice to join. I'm guessing it's, is it late night there at the minute? Certainly not early morning. Well, it might be early morning, actually. So these yellow here for sound, I'm pretty sure on my board, obviously, because I put the sound here, it's going to be at the top, which means if we then pull up the drawing, that the sound, so the sound here, would be at the top here, which means the writing would actually be upright. So maybe I didn't get that wrong, but I just want to double check in the actual PCB design. I didn't get that wrong, otherwise we'll have issues. Game gear, clean screen, hardware, no, not clean screen, what am I doing? That's the other project. PCB, hardware, one ASIC. I just really hope we haven't got any traces wrong. This would be nice to be. I think the two ASIC worked first time. I just missed the C clock. So I'm hoping this one works first time. It would be nice. Yeah, so sound is at the top. So it is correct then, which is good. Which means we can just hot air the chip off here, straight onto here. And that's all we've got to do. And we should be able to test. So it's that simple, really. Hot air anything. You can do the maximum temperature, maximum speed if you like on the Game Gear. So you could run 500 degrees and 120% airspeed if you liked, but I run 480 Celsius and 80% airspeed normally. This is currently set to 490/90 just to work a little bit faster. Where's the flux? I'll put it back. So let's get this chip off. And I think we actually can probably get a nice angle on the side view. Probably zoom in a bit as well. And get a nice little side shot. I'll take this one off. Yeah, this is a custom PCB I've made. This is the second one now for the one ASIC versions, the Game Gears that have a single ASIC. Obviously the prototype, so I've got no idea whether this works yet. I'm hoping it does. That's the whole point of doing this, to see if the design's good before we make it. And I don't want to be overly confident because I'll be disappointed if it fails, but I can't see me getting it wrong because we've already designed one that works, so we know at least the shape and function works, the USB works, the video RAM and the work RAM we know work, and so long as I haven't wired anything wrong or got pins wrong, we should be okay. But there's normally always some issue when you first make a board. And that's that one off. Ooh, drops it. And then we'll now go over to our PCB without stabbing my fingers with the tweezers. And I think, I don't know if I bent some pins dropping it or not, in that bottom corner. We've also got to make sure the footprint fits right, because that's the other thing. Yeah, I think when I dropped it then, trying to look at it, I might have bent some pins here. Oh yeah, I've completely smashed the corner of it. Do we bend them pins out, or do we just grab another one off? I should be able to bend them out fairly easy. It's a good start on it. Try and inspect my work. Look at that impact damage. Let's try and put this on here. Sorry, it's got me bother bend them into place. Let's move them out of the way. I mean, grab another Game Gear. It's quicker than messing around. We don't need anything. Oh, we need the extension port like that. Just grab another one. Which one do we reckon? Got two more. Ooh, zoomed right in. Zoom. Let me save that angle because that's a good angle. And then zoom out. No, this is late for me. Quite a few people always mention it's early. I'm normally starting work at 6. That's pretty much the standard time I'd start. I was a little bit late this morning. What do we reckon? Top or bottom? Which one shall we destroy this time? They both look... Top looks a bit more damaged, but that's not always a sign of whether you should go with it. Normally the ones that look more damaged are worse. They're both the same model. This one's made in Japan, this one's made in Taiwan. That's the only difference. Although this one does look, the top one does look very crusty. So, I'll just get this app up to focus. See if it still works. There we go. So yeah, see all the grime there. So usually the dirtiest ones work. So we've got an even split between top and bottom. I'm going to say, just because normally when things are dirty, it's good luck, they usually work, I'm going to go with the top one. And then we'll probably drop this one anyway, so I won't worry too much about it. I'll try not to inspect it this time when I'm working on it. Zoom in. And get that in frame. There we go. I think it was out of frame for the vertical people, actually, now I'm looking. So you probably didn't even see it get removed, the last one. And let's do this again. And I've also moved the top camera now because I've replaced the one above with a Blackmagic 6K camera now. I've moved it more into position with where I work because the other issue I had with the overhead camera is it was kind of forward on my desk. So every time I was trying to do the top-down view, I was having to work quite far away from the device, which was making it harder to work on. Now it's more positioned where I need it to, so I can do a little bit better job when I'm trying to record and work at the same time. And the other benefit to these is, yeah, seen a bit, Eddie. Thanks for jumping and joining in. The other issue with these, well, the other benefit rather to these is if there's a fault, it can pretty much only be the one ASIC. So you just swap it back out again. Right, let's try not drop this one. Let's place him gently on my board. Go over to this one. Move him in. Tap for focus. I definitely want to make just a little button so I don't have to keep using a phone to focus, but it's certainly better than reaching up above my head. We'll make sure we position this one correct, so I want to rotate this around. And we'll see if this is actually aligned. Let me look under the scope a minute, because one thing I want to check is, obviously I've made this footprint, so I've done it off measurement. I want to see if my footprint is actually correct and lines up nice. Otherwise we're kind of screwed if it doesn't, so that'll be the end of the video if this doesn't line up. Yeah, lines up good. It doesn't need to be as long as the pins are. Like, the pins are quite excessively long, but yeah, I think that'll flow in. It's hard to push into position enough with enough accuracy because it's already pre-soled, like pre-tinned on the pad, so I can't position it. But you can see from this, it's going to line up. Like, it's close enough that I can see it lines up. But the pins are quite short on this ASIC, so they only go to here, and then they extend out there. So they're a little bit, like, it's not a problem, it's a good thing, but they're excessively long for what we need. So let's just flux and reflow this. Yeah, the 2 ASIC version, the only mistake we had on that board, the first prototype, was I missed C clock. So on, let me just put the hot air down a second. On the chip here, there's a clock called C clock, and over by the Z80 on the schematic, I think it was written as CLK, not CCLK, so I overlooked it when I was doing the schematic design. So we had to run a jumper from here over to here, but that was obviously a prototype. We fixed that for mass production, and that's the point of what we're doing here. This is the prototype of the 1 ASIC, so if we find any issues, we fix them now, and then when it goes into production, we hopefully don't have an issue then. So I presume this is going to be pretty much the same timing as the 2 ASIC. Not much to watch out for here. If you're using hot air, you're not going to do any damage knocking things off. But as we just found out, the pins are quite fragile, so just be delicate when you're moving the chip around. You don't want to bend legs because they're very fine pitch, and I think that's going to be the most awkward thing, is if you've sort of bent the pins, that's going to be your biggest problem. Yeah, this is a repair channel. We don't do refrigerators though, and we're all online. We're basically retro consoles. So these pins, I might actually move the pins inward to the chip if it doesn't pull in, but hopefully it pulls in, because I've got traces running all inside this chip. It's going to be quite a lot of work if I have to reposition the pads. I think this one's a little bit more. That pulls in nicely, actually. I don't know if big head was blocking your view there, but I had to make sure that pulled in really nice. See if I can get it to do the jump again. I was like nudging it to check, and yeah, see the little nudge, you can nudge it out the way and it pulls back in. That footprint's actually there, fully centered. That's a really good footprint. So because the pads are further away on the outside, the pins try to pull naturally, so that's got a better pull than the 2 ASIC. I like to push down on these though, so I'm just going to like cool down a minute, set, and then reflow it a second. Right, I think a few pins are solidified, so push down, one quick reflow. Well, it's looking good for the first one. I certainly would not recommend using an iron on this 1 ASIC though. The pins are that fine. I think you're just asking for trouble. So yeah, if you're going to build these yourself, I definitely recommend just practicing with hot air. There's literally no reason not to hot air these on at all. And then just use your soldering iron to touch up any shorts afterwards. That's all I'd use it for. And this, oh, I know why this is taking a little bit longer as well. This will be factory solder, so it'll be lead-free solder. So this will have taken a bit more time to heat up. That's why it's like slightly longer than the 2 ASIC when I've practiced on it. So this should have already solidified because, again, lead-free solder. Let's clean up while it's warm. And then let's see what damage is done. Hopefully it's a clean install. Try to get as much flux out of the way. There we go. Right, so we zoom in. I'm not sure whether that's slightly out of focus. Let's focus on the writing, and then the pins should be in focus, which is what we care about. There we go. It was slightly out. Oh, tons of shorts everywhere, all along the top. So we're going to have to run some flux down here. Yeah, there's unfortunately solder bridges everywhere, and that's probably with the fine pitch of it. There's absolutely tons. So there's no way. I think unless you align that perfect, what we might do when we're installing these then is tack down a top and corner pin perfectly aligned. Mind you, you can't if you're not yeah, it's a difficult one, that is. Maybe that's just bad luck on that one, but I'll just clear up them shorts with an iron. Just basically use some flux and an iron. And then the more we practice, I'd like to find a way where you don't get the shorts. That's probably just more the fact I was nudging the chip around while I was messing, and watching it pull in and things. I probably caused a few more shorts than I typically would have, but your goal is to not have any shorts on this ideally. And this has got loads of flux on, loads of solder on my tip as well. I'm waiting for a new tip cleaner to come so it can really clean the tip of excess solder. So they're easy enough to remove anyway. That's one off. We've got literally almost genuinely nearly every single pin along the top is shorted to another pin. Yeah, it comes off super easy though. These footprints are actually really good. Probably don't even need the scope. I can probably show you this. So whether it's a good design on the footprint or not, but see these shorts here. Let me just clean my iron of a bit of excess solder, so I've got a bit too much on. But yeah, you just practically just touch. So ready for this? Gone, gone, gone. Look at that. And when I remove shorts from footprints, I can tell you now it's normally a bit more difficult than that. It's never too difficult, but that footprint with those long pins, it was a mistake, to be honest. I didn't think it was I've just slightly mismeasured with the vernier. So those pins are a bit longer than I expected, but that's actually worked really well. So that's something to note. Right, the shorts along here somewhere. Where are they? So yeah, see the shorts there? Those two joining the two joining. So we should just be able to tap, 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 gone. Like every one of them, all the way down. See all these shorts, nearly every pin. Just tap and gone. That footprint is crazy. I'm well impressed with that. And then this is now just, I've got quite a lot of excess solder on my tip, so clean that off. As long as your tip is pretty much empty, it just pulls away. That's really impressive. I think I might have discovered an accidental hack there. Long pads and slightly too far out of the footprint makes it really easy to remove shorts. That's genuinely quite exciting. I might do that on the 2 ASIC. Just extend the pins and move them out for the next revision. That's got all the solder at the top. There we go. So that looks good now, I think. I'll check under the scope, but that looks good to me on there. Do you ever find with hot air turned up, you don't have a problem with all the components blowing off? Not really, no, because Kapton tape's the worst thing to use. It will literally pull the components off or glue up on the board. You never need it for any reason. The Kapton tape's pretty much useless in anything. I've never used it. There's almost no components that are going to blow off because surface tension holds them in place. So once something's soldered on and the solder is on the pads of the component, it's very hard to blow them off. If you're blowing them off, you just got the temperature the speed of the air too high is what that is. So if you go on my YouTube channel and watch the old video of a Game Gear recap where I was just trying to show the recapping of a Game Gear, I literally blow off about 20 components in the video. They just go flying, but that's because I wanted to show how fast you could do it, and I wasn't really paying attention. As such, it was just meant to be a quick video and showing the technique, but I got the hot air turned up to like full speed, 120%, so components were blowing off everywhere. That's the only time you'll do that, and it's mainly poor solder or poor solder pads anyway. If that was reflown with fresh solder and then I did it, they wouldn't blow off. So generally just keep your air. The air is usually 80% speed for everything regardless of temp, and if you want to go careful, just turn your air speed down. That's the trick. Another thing I've noticed on this here as well, when I'm trying to look down into the pins to see if they're shorts, because the PCB is white and the legs are silver, very hard to see. So what I'm going to do is put black silk screen around. So say on here, it's easier to show you the empty one. I'm looking down like this, and where I'm seeing this gap between this black line and the pins, and you're trying to look down for shorts between pins and you're just seeing a silver pin and this white line. So I'm actually going to make this black line thicker to go right up to the edge and in a bit, so that when we're looking through, you see a shiny silver pin against a black background, because it's quite hard to see looking in there if you've got shorts. When I'm looking under the microscope, it's quite difficult to tell because they are so fine pitch. But I'm pretty confident that's on, and no shorts. So I guess we're ready to see if this thing works. I think we need to clean up a bit. We're already a little bit messy and sticky. I think I've got my extractor fan out and never used it. Right there. Yeah, for the tip cleaner, I've brought loads and they fail within days. So let me just pull up the one I've brought, because this is one Zach's been using now for about a month, and he excessively cleans its tips on the irons all the time, so we know it's functioning and working. And then you can buy one as well. My orders. Where is it? There. So pull up on the screen a minute. So this is the one I brought. Bit expensive, but the other option is you keep buying things over and over and they break. So this one works really well. If you just search for IAXUN CM30. Works very well. So I brought myself one of them. And then I brought some spare brushes. You can find the spare brushes somewhere. They pop up when you search for the thing. There they are. So you can get the spare brushes as well, because that's the only thing you'll have to replace. Clean the PCB from flux. Keep the board hot. That's the key. And then use a melamine sponge. So see how it's all soaked into this. The main key with cleaning flux is literally the board should be barely touchable. The solder should have solidified, but it should be just like under that, so the board is stonking hot. And then flux on a melamine sponge, push down and rub, flip the sponge over, rub again. And then once you've so far down the sponge, cut it with scissors, because it's going to get soaked with flux inside, and you can use it for a good few jobs before you have to swap it out. All right, then, moment of truth. I feel like I'm forgetting something, because all we have to do is put a crystal on and that on. Those ribbons can go on after. The audio can go on after. We need the speaker for sound. I think that's literally all we've got to do. I hope this works. The other thing as well is the crystal. We're still using the prototype, well, not the prototype now, the mass production crystal, but I've only installed about 8, I think, so far. So the resistor might need tweaking on that as well. There's a lot of things that could go wrong here. I'm not even going to start with screen. I want to, that's a good thing or a bad thing. I'm just going to start with audio. Let's see. Probably get nothing at all. It could be anything if that's the case. Oh, no Sonic. Try reset. Oh, nothing at all. So, do we just clean Sonic? See if we can get a load. Right, that's good in one way. The sound means the ASIC's probably running. Have we got a bad Sonic, maybe? Because this happens loads to me. I find the games work and then they don't. Let's get another game. And we could just have the obvious that we've got a bad ASIC. We don't know. So, on camera, find me again. But I'll get the scope out in a minute if not. Tell you what, let's put the screen on as well. Let's just out of curiosity see if we see anything on screen. Well, it looks like a no-go for now. The fact this works though, if we go over to here. Oh, where's the camera? Oh yeah, I keep forgetting the camera's now in the position where we're typically working. So the outer reset, holding reset, is bringing it out of reset. So that's one thing. It doesn't always mean it's working, especially on the one ASIC, but yep, nothing there. So let's just plug a screen in, see if we get anywhere. That there. And I'll probably use, because I have prototype ribbons made as well from the new factory, but I'm going to reuse the existing ones for now, in case that becomes a problem. I'm hoping we just got a bad ASIC, because, or the two things I'm thinking it could be, the most likely things are the crystal isn't spinning up, and we just got to get the resistor right, and that'd be an easy fix, or we've got a dead ASIC. They're my two hopes of the problem. I'm hoping we haven't got an issue with the design, but there's no saying I haven't messed something up. But really, we'd have to swap a few ASICs over first to be confident, because we could just well have these are literally, I suppose what I should have done is found a working game. You get a working one first, so you know the ASIC's good. That's like the logical thing to do. Interesting. Okay, that's there. So we're getting no border whatsoever. Let's hold all the buttons to check the clean screen's working. Yeah, so that's saying green. We're not getting H. So one of the things, H sync or V sync, I can't remember. High frequency is just the ASIC operating and not generating sound because it's not loading data properly. You're just hearing random instructions operating, and because the ASIC isn't effectively operating right, instead of generating sound on the sound pins, it's just in an unknown random state, so you just hear noise. Let me just see if there's any issues. I may have put it on the right way. Yeah, it's really difficult to see for shorts because of the pitch of these pins. It genuinely is hard to be confident there's no shorts. I'm going to have to get the angle just right. Right, there's an okay angle. Yep, so they're good. They're all good. They're all good. I think it's this way. These are probably going to have to be over the edge to see them. Yes, there's definitely, as always, not really an issue with soldering. It's very rare that is an issue. Let's get the scope out. Let's see if we've got clock. And there's also, again, a chance that we've already seen one of the prototypes is missing a component. The components could be the wrong spec. They could have installed things wrong. There's so many things that can be wrong. So you can't guarantee anything until you get a successful build first. So let's start with the obvious. I'm an engineer, no, just the self-taught guy that messes around. That's that. Let's get that out of the way. No, that Xbox, I've still got the Xbox with the frag issue lying around. I've got a few more as well. At some point I'll get back to that and maybe write some software to diagnose the problem. But until then, it's just stored away. What do we need? USB to power it. And then let's get this booted up. In one way, I hope we don't have clock, because that's a really simple fix. That's just a resistor change. Let's put this over here. Right, so now we can pull up the scope over the top. Hey, welcome from Spain. Yeah, this should work on a VA45 as well. It doesn't even work on a normal one at the minute though, so we've got to fix that first, but yeah, it should do. Oh, we've got clock. I was hoping we didn't have clock, but is it the right speed? Measurement, frequency. Yeah, so the clock's working, so yay for me, our clocks work. I didn't want it to be that though, so VREF, I guess we should check some basics. VREF is grounded. V on off, if we take the trigger off, is top. So 1.2. V resets, obviously 1.6. Yeah, so to be 1.6 to reset, yeah, that's fine. Out of resets, obviously 5 volts, that's fine. Sample pin is, yep, that's operating at what we expect, which is, can't see because stuff's in front of my screen, 16.11 megahertz. I'm not sure whether that's normal. And the sample, when you hold reset, the sample pin's still pulsing. Not sure whether that should be the case. Out of reset, then I presume we're grounding. Yes, that's the other thing to see if the ASIC's controlling the reset line at all. So when we pulse, it's just purely static. So maybe this ASIC is just dead. So we're getting clock, which is, good. We wanted the clock. We're getting the sample pin, which shows the ASIC's doing summit. And the sample pin, if you zoom out far enough, is actually in cycles. I guess we could also just put the audio in. Could do a bit of probing on the data and address pins, just to see if anything's happening. So if we go to this view, then we can probe like the right pin. So to be honest, I think it is trying to do something. Let's pull out the audio for now. Does look like it's operating. Let's go down to there. So the right pin's constant, address pin constant, or if we zoom out a bit, I bet it's, yeah. There's a cycle going on of attempted read and reload. That one's pulsing. That is, I'm not 100% confident it's going to be the ASIC. I mean, it well can be, because obviously all these pins will operate, but we do have quite a bit of life out of it. So data pins are doing what they should. Now, IO request, is that the IO request pin? No, that's the read pin. Read pin's never reading. Maybe it says, there you go. So you see that first, you press, what I'm doing is pressing reset. So I'll press reset now. Tries to read, then fails and goes in. Oh, no, it hasn't failed this time, but that isn't. Hang on, that might be running. Try to keep it still. No. So that was like it was running though. That's the IO request pin is typically when code is operating and it's requesting stuff. So the read pin is pulsing. Everything seems to be pulsing. So obviously, I doubt we've ever got broken traces on these, but it's worth a quick check. And every single pin seems to be doing something. The 5 volt won't matter. The M won't matter for game load. That is typically though. That's normally what you see when it's run. Well, no, I say you do. This is normally a lot more erratic. That's fairly steady. So that's probably just obviously not loading correct. C clock we've got, which is what we were missing before. SMS doesn't matter. Sound doesn't matter. So before we go and swap the ASIC, everything seems to be operating fine there. There's nothing I can see that's technically looking wrong, but like I say, ASICs can just fail and look correctly, just can't internally process. We've got, let's see what chips we've got on for the RAM. RY6264, I'm sure that's a known make. RY6264, yeah, so we've got, now the thing is, if we look again at the difference in the two, so the known working ones at the minute, this is the new prototype, and then this is the ones that we already know work. So look at the difference in silk screen. That's a reprinted silk screen. Doesn't always mean they're not going to work, but is it worth just quickly swapping that over for how easy it is? Let's just put the known working RAM on, because like I say, you can't presume the factories are sourcing these older chips from good places, especially when you change factories, because these chips are very old. These have been reprinted just to look nice, and usually if they look faded, they'll reprint the silk screen on when they're selling them, but they are genuine. But a lot of the time, as people know, is you can also get non-genuine chips where they just reprint a silk screen over the top and say change the speed. So this is like a 70 nanosecond chip. They could reprint, get a 150 nanosecond chip, which is too slow, potentially too slow, and just print on 70 so that you think you're getting the right speed chips and they're not. So considering we know this 2 ASIC works, I'm just going to rob the RAM off it, and then we'll test the 2 ASIC actually still functions. And we can also test, I guess, the clean screen and the game at the same time. Let's make sure the other stuff we're using is working. The The one thing I noticed on the 1A6 schematic as well, when I was copying the original schematic basically for pinouts, is the 2ASIC has one of the data pins on, I think it's this workram, that isn't connected. But on the 1ASIC it is connected, and I double checked to make sure, and the schematic does show it connected. But it could well be the schematic's drawn wrong, and maybe one of the data pins on here does need disconnecting. That's something that obviously we won't know until we either probe the original board to confirm that, or we just try to, we disconnect the pin. But the simplest thing would be, and I probably should have checked the original before I did it, but it's not that big of an issue if it is. We can check an actual 1ASIC PCB in continuity and find out if that pin really is connected. And then I don't know whether we might do one other ASIC swap, and then it might be worth trying to get a one-chip Game Gear working first, so we know the ASIC's good. Otherwise we're shooting in the dark again, guessing if the ASIC's good or not. So that's probably the smart move. Right, I guess we can try. Right, let's try this 2ASIC first. Let's prove that this game works. The sound, well, ideally, we want one that starts sound as soon as possible, so we'll find out the best one for that. And we'll check the clean screen works as well. This is a new clean screen, so we want to prove everything. Yeah, PS3s were doing dozens a month, if not more. We stopped working on them just because they're all failing. As you know, the RSXs are just failing, and it wasn't worth it. We just got sick of doing them ourselves. Reflowing, reballing, and just nothing had ever last. Like that, within 6 months, every single PlayStation ever fixed PS3, the RSX would die again. They are genuinely just on the way out now, and I don't really want to be doing the BGA swapping from Slims. It's not exciting, and it'd be monotonous for me. We'd get that many of them in because no one really does it. That's all I'd be doing, and it's not something I'm interested in, basically. It's just one of them. Right, so this is the clean screen, the game, and the speaker in the 2ASIC with the workram off our prototype, which I doubt's a problem, but if this all works, then we know that was all good, and all our setup was good. Interesting. That doesn't work now. But is this game any good? And I'm sure this was a working. Oh yeah. Interesting. I'm sure this was fully working. That's a good sign then, in one way. I don't know what to make of that. I'm sure this was working. I'm sure it was. Alright, okay. Let's put that workram back on then, because I probably should have tested it before I ripped it off, but yeah, that's strange. I could have sworn this was working. Well, it's not strange. If the workram is bad, then that explains it, but I should have just checked the 2ASIC before I ripped the chip off it. But it's only a quick swap. It's not that hard to swap this back out. Ooh, mouse is clicking. I noticed as well the reset button's a bit dirtier and low quality, I think, on this prototype. So it's all just notes that. Oh, actually no, this is the 2 ASIC. The button on the prototype's actually nicer than the 2 ASIC. I thought it was the other way around. So I'll probably use that one. Keep them on. I'll probably use whatever button we're using on the 1 ASIC on the 2 on the next batch, because it looks a bit nicer. It's like just brighter, basically, brighter and a little bit taller. Right then. So that is the 2 ASIC back to where it started, which I'm sure was working, so I was taking out the tub of ones I've built that I'm sure I've tested before. So if this works, then we know the work RAM they've used on the prototype's bad. But we should probably, I think, find a working 1 ASIC before we proceed any further, otherwise we are definitely going to end up down a rabbit hole. No, the boards I'm making, we don't bother with the new screen support. We could potentially do it in future, but it's just one of them that it wouldn't be that hard. A lot of the complexity of the old PCB is all a huge amount of work to just generate. Well, no, actually, it is. Thinking about it is a little bit more work, but a big portion of it's just generating the negative voltage pulses, which you can do now much easier with just a negative voltage rail IC and a transistor to pulse it on and off. It's not that hard to remake that part of the circuit with like 2 components versus about 30 and a transformer. The backlight's another problem, but you could have, what I'd do is have a 5-volt LED backlight, and you could support that. So it's possible, but at the minute, it's not even on our radar to do that. Right, let's see if this now works. No. Oh yeah, there you go. So work RAM's bad. Yep, every time. That's a good start. So the work RAM is bad. So do we nick this work RAM now? Or do we put that work RAM back on once more? Just do the double check to make sure it still fails. Nothing's changed, nothing's moving. So let's put the work RAM that was on the 1 ASIC board back on. So this is the 2 ASIC that does work. This is the 1 ASIC RAM. Let's put that back on the 2 ASIC again, just to double check it wasn't bad luck or soldering. Let's just whip him back off once more. I always like to double check when something doesn't work, then you put something back on and it works. I like to just take it off once more and absolutely guarantee it wasn't like, a soldering issue. I think original Game Gears as well, with working original screens, I'd personally try to keep them as original as possible because they're getting rarer, so they're obviously going to be harder to come by. I struggle now to come by a working original Game Gear, like with fully working screen and stuff, so you definitely want to start preserving them, I think. Right, so if this fails, we know the RAM's bad, which might have been our only problem. We could have obviously powered up the board, but that's a good start, because without work RAM, we saw a very similar issue putting this RAM on, which was just a coloured screen and static sometimes. Now, I can't remember what happened on the other one when we were resetting. We didn't even get screen, did we? But the 1 ASIC and 2 ASIC will act differently. So the chances are, if this still fails, which I expect it will, then that might be our only problem, which would be good. Just let this cool off a minute. Yeah, I did have. Well, I had all of them. So before I made, obviously, with I say we, but my company, we, are the only people in the world that have ever made the shells for the Game Gears. I've made them for loads of consoles, but we're literally the only place in the world. If you buy a new Game Gear shell, it's the one I've made. Originally, we released every colour. So we had cream, yellow, blue, red. All that come from me buying every rare Game Gear that you could get, including like £1,000 cream Game Gear, complete in box with everything. I sacrificed every one of them to send to China to clone the colours. So they had to cut the plastic, melt it down, print silk screens on. They basically had to destroy my nice collection to remake the Game Gear shells in really good colour representation. So much so that I actually did a test, and I think it was online as well as in person, to say, like, here's my cream shell, here's an original cream shell, tell the difference, and nobody could tell the difference. Even side by side, you just mix them around, you couldn't then tell the difference. So all my ones were sacrificed to make the Game Gear shells, basically. Same with the PC Engine GT. The RePCB I made for the PC Engine was a pristine working Game Gear. So it's not that, so that was just bad soldering. That's a shame. So at least we know that chip's good. We might as well put this one on. We know all the clean screen's good, the game's good, the speaker's good. So we've proven that now. So I think we'll do probably one ASIC swap more, because we've only done one, and it can well be bad. And then if that fails, I think we want to get a working, like a known working Game Gear, so that when we put in the ASIC on, we know if we're dealing with an issue on the board or just a bad ASIC again. Oh yeah, it was painful to dismantle the PC Engine, because they're expensive, and there was nothing wrong with it, like absolutely nothing wrong, but I needed a pristine one to get a perfect board scan. So gutting, a literal full working PC Engine was quite something. And then we've rarely sold any of the boards, so even though I did all that to help the community, we sold a few at first, and then we could literally go all month and not even sell a PC Engine RePCB, which is a shame. But I've got one coming up, so I've got three. Got a PC Engine I need to try and get onto today or tomorrow, with a screen swap. So it's having not the best screen, but the only one on the market at the minute, with a TFT and a new lens. But then I've got one coming up that's a full board swap into our RePCB. So you'll actually get to see that on live stream. And then maybe a few people will buy it. That'd be nice. Right, so that RAM's back on. I doubt this will work, but let's give it a go. And then if this doesn't work, I think one more ASIC. And if that fails, we definitely need to find a working Game Gear, at least to the point where it boots with sound or something. So we've got, all we care about is sound at the minute. We could just be dealing with the obvious, just a bad ASIC. It's very likely, because this is coming from a tub of... this tub I'm working through now, I actually brought from somebody in America. I brought like, 50 Game Gears they just couldn't get working, and they work on them all the time. So all the two ASICs I brought off, and that's what we worked through. Well, a mix of it was mine and a mix of it was theirs. There wasn't many two ASICs of theirs. But yeah, they basically couldn't get... Where's my speaker gone? They couldn't get the Game Gears working, so the chances are most of these ASICs I'm picking up could well be bad, because these have literally been worked on before and they can't get them working. Yeah, no change, as expected. That's a shame. So, just keep pressing and hope. Yeah, nothing. Now, I suppose, I don't know why I'm not probing that. Why don't we just actually probe the video out? Because the clean screen's telling us there's something wrong with the like they're not getting a H-Sync V-Sync. So let's just check I haven't messed that up. Might be something, mind you, we'd still get game load, so I doubt it's that. But something in there. Out of curiosity, let's take a look at what's going on with these pins. So it will be P-Clock we've still got, H-Sync. Where's my mouse? Right, frequency 15 kilohertz, so that is correct. So H-Sync is there. There's no V-Sync. So we get no V-Sync, which is, I'd expect you get V-Sync even if it was bad. And obviously V-Sync M has nothing to do with it. The M is for Majesco VA45s. So these with M's in are specifically for where when you see VA45s. Same with like the invert. So on this board, this doesn't mean anything specific about the VA0. So I'm going to say we've hopefully got a bad ASIC because V-Sync has not got anything on. But let's just double check on the wiki first. Let me check if the wiki has the pin out for the V-Sync pin. Let me make sure I've definitely got that right. Yeah, so you can't really go, oh, that's the 2 ASIC. I was going to say you can't go wrong because it's the bottom corner. CL2DW, yes, they're all in line, and then it's CL2DW there. DW, CL2, yeah, so we want DW. I can't see me getting that wrong. It's next to the data pin. Let me check the schematic, like my redraw. Oh, pin. Again, say I've done it completely wrong, but it's rotated. That's why. So it'll be over this side. Reset P-Clock. Rotated backwards. So I'm browsing my design file for this at the minute. That will be furthest over. V-Sync goes through there to the, yeah, so it's definitely the right pin. So there's nothing wrong with schematic wise, basically. So I think one more ASIC swap, and let's hope for the best. I'm suspicious it's going to be that. So the one we have left is the one from Japan. So we actually did the one from Taiwan. So this is the Japan one on the bottom. So let's hot air them off. See if we can get a nice close-up view of that again. And let's hope this one works. So, it does look good though. It does look like, from quick glance, all the pins are pulsing. They all seem correct. We've got clocks. We've got sample pins. From a quick overview, let me just whip this old one off first. A quick look at it so far, I do believe it's going to be functional. I think we just got a bad ASIC, hopefully. Nothing's standing out to me at the minute like a problem, which is good. Yeah, I've got it's another thing I brought, the PC Engine with the CD-ROM add-on, all boxed from Japan. I only brought that because I needed to fix one. We don't now work on anything really with CDs anymore. But I brought that just for being able to compare. So I've got one of them all nicely unboxed. I think it was about 600 quid maybe, I can't remember. It wasn't cheap. yeah, I'm going to redo this solder as well for leaded. So here's a potential bad one. I'm just going to redo that with leaded solder because that's taking quite a lot more heat to get off, which we don't really want. Oh, is that just a... Well, I think that's just exposed a trace, just running the iron over it gently to reflow the pins. That's the problem with the prototypes, though. It's like I say, they aren't produced the same way as mass production, so this board isn't going to be the highest quality to begin with until we go into mass production, but didn't expect it to be that bad. I'll just show you what I think has happened looking at it. Where are we? Yeah, look at that trace. I've just been dragging solder down and it's just like remove the silk screen as I've been dragging solder, and we've got a solder short that doesn't want clear, so my guess is going to be those two pins are joined. Let me just check the schematic. No, they're not. It's quite annoying because that should not be joining and that should be clearing off easier than it is as well. It doesn't seem to want to clear with the iron. What is that? Definitely on the trace. It is, isn't it? So that's exposed the trace. There's no trace there. Oh no, there is. Ignore me. The pins I can't see are ground. So that's just two ground pads. That's why they're joining together. The bottom two are ground. Let me double check on the original schematic. Yeah, two grounds. That's why it's exposed and shorting together. So that's not a problem. But that's obviously poor quality silk screen on the prototype. Basically, that shouldn't happen by just reflowing. But we don't need to be concerned about these two pins shorting. Basically, that is two ground pads. So now let's get the new one on. Oops, do that. And I don't know whether to do this. I'm going to probably reflow this under the scope just so I can be sure I get it in one go. I want to kind of take this off and then get it on the board in the best position. Soldering, I always solder it. I think it's 390. Let's have a look. Yeah, 390 is pretty much my standard for most things. I bet there's a ton of bloody TikTok chat as well that isn't popping up again. Let's see. I've got to wait for all the messages flooding. Yeah, so TikTok chat has not been popping up again, so apologies for that, guys. I've got tons of messages. Let me just... Oh, yeah, there's absolutely tons. I'll try and scroll up and read through these TikTok ones while we're taking this off. I thought it was strange that there was no one coming through. Game Boy Modern, no, this is obviously Game Gear. Yeah, the white PCB is definitely the best colour, that's for sure. Got some good luck in TikTok as well, I've missed. That's why we're not having good luck, because I didn't see the messages. Dribs, that's me. Can you answer the question? I haven't actually seen, so probably ask it again now, because I've obviously only just noticed TikTok messages aren't coming through. At the minute, not very well supported in Streamlabs. So just ask again, I'm sure I'll see it in a minute. That's that one off. Turning that way. get under this. I've still got tons of TikTok messages to go through as well, so let me just get this on, and then we'll go through the messages. While that's warming up briefly. Can we repair fruit machines? We can. We've done them in the past, but we don't anymore. We keep things limited to the main repairs we do because we have too many already. For heat, it's I'm using 490/90, but it's normally 480/80. And this is the VA2, but it will work. This board should work with VA45 as well. So once we get it working for this one, we'll test that it works for the other as well. So this should be a universal board for both. You shouldn't have to do anything magical to get it work for both of them, basically. Yeah, this board does actually absorb more heat than a 2 ASIC, to be honest. That's taken longer again to reflow on than the other one. Right, I think that's good. You guys can actually see something again now. Xbox controller question. Yeah, just ask again. I'll carry on reading down. Yeah, so it actually looks like TikTok worked at some point randomly because I've seen a few of these messages. We're not repairing, we're testing a prototype Game Gear that I've made. Specifically a 1 ASIC, one with one chip on. Literally you transplant one, so you transplant this ASIC over. It'll come with the crystal on. You'll have to put the power and audio wires in, but they're super simple, and the extension port's optional. So basically, if you want to work in Game Gear, you can just literally transplant the ASIC over. So it should be much simpler if we actually get it working, that is. This now, let's have a zoom in and check. Still got a bit of flux still wandering around the pins we need to try and get rid of. But I have just checked this under the scope. Let me just get the focus back up on this. There we go, so that one's okay. Other than the slight yellow of the flux we haven't cleaned. These bottom two are the ground, so they're meant to be joined. Those are okay, just a little bit of gunk on. So that's just grime in between there, I believe. That's actually just, again, the silk screen exposing the pre-preg between. It's just the quality of the silk screen on the prototype's not good. That's good, and then that's just all that gunk under there is just the flux. There you go, going. So you can see the silk screen's weakening on this. That's what these little black exposed bits are, but that's soldered. I'm confident that's soldered good, so let's just try that. I've got a feeling it's going to be exactly the same, no matter what, but sorry, let's just try. We can but hope. No different, unfortunately. Well, I'll say no different. Yeah, no different, I don't think. That's a shame. So it does look like we're probably going to have a fault somewhere, or just bad ASICs, but I think we might have to get a working one chip at this point to make sure we're definitely we're dealing with a working ASIC, because if we are, which it's not unheard of, we've had multiple duplicate problems with other ASICs. Then we could have a fault on the board. We might have a missing trace or something wired backwards. I need to try and find a game gear is the problem. That's one of the biggest problems. We don't have working game gears because we sell them all. What flux use this Styri flux? Use Styri V3, I would, at the minute, as the main one I like. We don't do shell swaps on Steam Decks, no. Right, let me go back to this chat, see if normal chat. Where did I get the speaker from? IPA plunger. Speaker's just Amazon. Just search for 3.5mm speaker and you'll find a load that look like this. You should just spot that shape. It's a fairly distinctive shape. These, again, Amazon, just IPA dispenser or fluid dispenser, and you'll find multiple versions. The pink lid ones seem to be the best for me. What do we do now then? Where am I going to get a working game gear from? I literally have none. This is a dilemma. Right, let me go grab another coffee and go hunt for a game gear quickly, see if I can find any that haven't been, well, that at least get audio or something. So I'll be back in a second. back with coffee and a yogurt. Here is my only working Game Gear out of my collection. So it's got the original screen. Everything works original. Don't know what the sound's working like, but yeah, it does. So completely stock, working original. So the question is this one a 1 ASIC? But just before that, let me just check one thing I mentioned where what I thought odd on the schematic was that covered in dust. Let me pull up the schematics, see if I can find where and show you. Because I thought it was odd when I was doing it. I didn't really check, I just trusted maybe. With it being a 1 ASIC, it was obviously like correct basically. So VA1, right, pull that one up. And then pull up VA2, so this schematic here, right? So if I pull up that, Nintendo handhelds today, no, this will be this Game Gear, and then I've got an Amiga I've got to do, and then a PC Engine. Right, helps if I pull up the right screen. So this is the I've pulled up two 186. Why is that named VA1? That's VA2. It's a 1 ASIC. Yeah, I've got two of the same schematic. I've got both of the 1 ASIC, but actually that was a good thing to show. So the original drawn schematic, if we go to the data here, see all data pins D1 to 7 go all the way up. A0 to A14 go all the way up and connect, and then a bit clearer view you can see on here, same thing. So all the pins connect. This is this 1 ASIC. If I pull up the 2 ASIC, this is where, because when I was making it, I was really questioning whether it was correct. But if we look on here, I think I've been looking at the right thing. So look at A7. A7's grounded on the work RAM. And then just to make sure I'm not going crazy, you go back to the other one, and A7 is definitely connected. So I can't see that being a problem, but for whatever reason on the 2 ASICs, A7 is not connected to the work RAM. So let's just double check that that isn't a schematic issue, basically. So that will be, if I've done it right, pin 68. So let's just check. I can't show you my RePCB, but let me just check my schematics correct as well while we're doing this. So this will be pin 68. Well, to be honest, I can show you my schematic. It doesn't really matter. People copy your stuff anyway, and it's not exactly giving away secrets. So if I just minimize that, unpin that maybe. Okay, just drag it in for now so you can actually see something. This is the literal 1 ASIC. And you can see A7 goes around and connects, and A7, if you start at this end, it will be up, so A7 is there. Is that right? Or am I? No, sorry. We're at video RAM, so it's the video RAM with an issue. So to be honest, even if the video RAM was wrong, it's not going to stop anything working because it's purely video RAM. So you can see AD7 is pin 68 and pin 3. And then if we go to here, AD7 is pin 68 and pin 3. So there's no issue there, but what I wanted to just double check is on the schematic, we want pin 68 rather not 67. So 68 will be up here somewhere, is it? Right, so pin 68. There we go. So we want And have we got pins here with these two ground pins? Yeah, so we've got 1, 2, 3, 4, 5 pins down. Should connect to the third pin down of video RAM. That's what we're looking for. So that means the third pin down. Oh, video RAMs. Oh no, video RAMs. I thought it was going to be underneath. So the third pin down. So this bottom third pin here. No, sorry, top third pin here. This top third pin here should be 1, 2, 3, 4, 5 pins down from the Sega logo, which was on. Which way was this on? Was the Sega writing coming down? Sega this way, I think it was, wasn't it? In which case it'd be the 5th pin down here. So let's just double check that's true. But like I say, that's not going to stop boot anyway, so I'm kind of... I don't really need to be doing this bit, but let's just see. So 3rd pin down, if I've got all this right, it'll be... schematic's wrong. Oh, that's concerning. Oh, tricky. Why is that? I think I've maybe just got this. Let me just double check. So I think I'm doing something wrong on here. Let me just get a picture of one ASIC up. Let me check which orientation the chip was on. Something's not quite adding up there. Game gear, reading game slot, scroll down. Ground. So I don't think that's going to cause an issue. But if I pull this over, we've still got the screen share on. Where's my mouse gone? There. No, I haven't got a screen share. Let me just show you what I'm looking at the minute. Let's put it full screen. Even on my wiki, I've actually written that A7 is ground, even though there's an AD7 pin. So 1, 2, 3, 4, 5 pins down should be A7. So D7 is data, A7 isn't. But maybe my wiki is potentially wrong on the one ASIC as well. But why did I write ground on here when the schematic doesn't say it's grounded? So there's something going on there. I don't know how much to dig into this because that's not ultimately going to be the problem under here. That's like not really the issue, if you know what I mean. It's a video RAM issue, so you're just not going to see something on video, but we're not getting audio anyway. But, I mean, the sheer fact we have the pin going somewhere is concerning me. So, 1, 2, 3, 4, 5. This pin is going somewhere, and yet it's not going to where it should. So I'm a little bit concerned here with that, basically. Like, where the hell's it going? So 1, 2, 3. Let me pull up AD9. Let's see if any of these are connected to where they should be. So AD9 wouldn't go anywhere because there's no 9. It only goes up to 7 and then jumps to... Oh no, it does. AD9. 1, 2, 3, 4, 5. So this third pin, for example, should go to the 1, 2, 3, 4, 5 pins down here. So that's right. So the schematic's right in one way, but if so, is the third pin here grounded for sure? Yeah, so that should be grounded. But then, oh yeah, so that address pin will also go no, actually, that's the point. So where's this going? That is... something is not adding up here. Let me bring my schematic over to my full screen so I can see. So the address pin should only be going to the video RAM and nowhere else. Yeah. Just have to bear with me while I work through this and figure stuff out, because something's just not adding up with where this is going. Let me see. I believe I've got on the wiki some board scans as well, hopefully. I think it was Math that did the board scans on the one ASIC. Oh yeah, we don't have the solder through, so this is going to be a bit of a pain to trace. You have to go back and forward between the images. So let's do this, I guess. Let's screenshot that. What we're going to do is just trace this board visually. Let's just check where it's going, because I'm more curious now as to why the AD7 is... Oh, I know where it's going to go to. It's not that curious. It's going to go to a data pin, but let's still do this. It's going to go to the data pin of the video RAM, I'm sure. That one in. And this one. You'll see something in a second. I'm just... I haven't gone crazy. I'm not talking to myself. I'm just figuring this out. Why is this pasting the exact same image over and over? Come on. Give me that image. Oh, wow, this is annoying. There we go. Right, drag this over. I've got to do that to there. Right, I'll pull this up on screen now so you can see me doing something instead of me just sitting talking to myself. Right, full PC. So what I want to do, bridge, if you're on about the bridge at the bottom left, that's just 2 ground pads that are meant to be joined. The silk screen's just broken down. So what I want to do here is align these up visually, so I can kind of fade this in and out, and try and move this over the dots. So you can see that then, if we've got it roughly in position, we can hide and go between the layers. So if I hide that here, we've got pin 1, 2, 3, 4, 5. So this is the trace we want. Going up, going cross-eyed already. 1, 2, 3, 4, 5. Up, up, across, up, up. So this one here, this third, if we make a new layer, make a dot, and I'm pretty sure this is just going to go to the data pin of the VRAM, and then we've got no issues, but I just want to check. So there's the red dot, hide that layer. Yeah, comes back down. So you can see it goes down here, down here, down to here, down to here, back up, and to here. So pin 1, 2, 3, 4, 5. And then we check the wiki, which I've moved back over. And we went to Game Gear, reading game cards. That's where I originally started this wiki, so all the images are in here. We can see on here then 1, 2, 3, 4, 5, D7. So my wiki's correct, and I mustn't have gone off the schematics, but the schematics are wrong. So if we were to follow the schematics, then they are technically wrong. So I think we've closed. So yeah, schematic here, A7 to AD7, that's wrong. This is a completely wrong schematic. The original scan, A7, oh, I overlooked it. A7 is grounded on there. So The only thing we have is A7 needs to be grounded on ours, which if we went to the wiki, we can do it quite easily just to prove it's not a problem. The third pin up, we just need to lift and then send to ground. So that's what we can do, but I don't think that's going to cause any issues because I've got nowhere for my coffee. I'm going to have to drink it. The video RAM doesn't give any feedback, so the fact it's... I don't know, there's a chance. I'm just thinking the video RAM doesn't give feedback, but that could corrupt the data lane of the video RAM, and maybe the one ASIC can detect that the video RAM's corrupt. I doubt it, but we don't know. We've never seen it, so still worth investigating. So pin 3, I can do this one this way, can't I? Anyway, pin 3 on this, we need to lift up and then ground. So we can, is my head, oh yeah, big head gets in the way. I don't think this is going to solve the problem. Like I say, this is video RAM specific issue, but it's certainly, we might as well fix it. So warm up the pad. We do with bendy tweezers where it goes at Nick Zach's a minute. Right then, get these under. Bit of flux to keep it flowing. It'd be interesting to know that if the ASIC can detect corrupt video data, which I can't see being the case there, but that's that. Oh, I just did that with my head over the camera again for you. Right, that's well and truly in the air now. And the ground, I believe, is, I think it's the top pin, isn't it? So let's have a look on the wiki, pin 14 and 28 now, so it's not ground. Keep closing the wiki, I should just keep it open. Game gear, reading game cart. Ground is the other side, so ground's down here, top left. So I'll send a wire to there, and then at least that's matching the schematic. And you watch, after all this anyway, we'll just have a... I wonder what happens if we get it working, we'll unground that A7 as well. I wonder if it does something, like do we see any extra video detail? Do we get extra colours? Could well be that, like, why has the ASIC got a pin for A7 if it's not used? You know, maybe there was obviously a glitch or something, but it would be interesting to put A7 back to where you'd think it would go after this to see what happens. Might find some extra pixel data. You might even use it for debugging. Like maybe you'll see, you know, maybe they use pin A7 to overlay something. Be quite cool if it was. Ooh, I can't use these blue tweezers now. I'm used to the other ones. Right, so that's now grounded. Doesn't have to be pretty for now. Put them tweezers back before I get told off. And will this change anything? I doubt it will. But you never know. Game's in. Sounds on. Nah, no difference like we thought. Yep, so there's only one other thing I do, because I'm trying to make this work for VA4 and 5, is I actually I purposely ground a certain pin that the VA4 and 5s are grounded, but they're not grounded on the one ASIC. But have I made a note? Yeah, so pin 41 I ground for Majesco specifically. But what's pin 41 on the one ASIC? Pin 41 is A. 1, 2, 3, 4, 5. So 5 pins over. So this is another difference that I don't know whether it's going to affect it. but the 5th pin over on here, 1, 2, 3, 4, 5, this 5th pin here, are ground because on Majesco's that one's grounded, but on these VA2s it's not grounded. So I probably should have put a resistor on there in case this was a problem. I can't imagine it being a problem because it's just the pulsing output for the video and it's not a feedback pin. So, oh no, it's not that pin, sorry, because it's rotated, but it is the A pin. This rotation thing gets me every time. Pin 41. In fact, I could maybe cut it 1, 2, 3, 4, 5. So it's the 5th pin up on here. So I reckon let's just lift that pin because that is a difference. And I'm probably going to have to do that under the scope, to be honest. I'm not going to be able to do that without. I think I've got some... where's the really pointy tweezers? Let me just get the curved ones again. I do have a curve, actually. Yeah, I do have one myself. Somewhere. There we go. So I don't have to keep nicking other people's tweezers. There we go. So let me just do this under the scope. 5th pin over. We want to lift up. It'd be interesting if it is that. Oops. But we'll see. Let me just go back to stream chat as well. I'm having to bounce between 2 chats here because TikTok's not showing up in the main one. No one's chatting anyway. I'm talking to myself. 1, 2, 3, 4. Ooh, put a bridge on while I was doing it. 1, 2, 3, 4, 5. So, this is going to be a nightmare. This is going to be... These are really fine pitch. Yeah, damn, that's quite hard. I might have to blow through the board if I can and cut a trace. I think I'm going to have to try and cut the ground. There's no way I'm lifting that pin. It's too close. But luckily, because I've got obviously the PCB, because I've made it, I can see where the traces go. I can just cut through. 1, 2, 3, 4, 5. Definitely this one. There's a dot just above here, so I can just blow through that. In fact, I can grind a pen there. Yeah, definitely. Just watching and waiting for the fix. That should be accurately cut out if I've got my skills working in my favour this morning. So we go onto here, go down. You can see we're cleaning it up with a bit of IPA. You can't really see because I don't think we can zoom in much more. Or are we not zoomed in all the way? Yeah, we're zoomed in all the way, so we can't get much closer than that, but there is a via I've managed to cut the trace perfectly there, so now that pin isn't grounded. So whether that helps us, it'd be good if it did, but we'll see. No difference as suspected. So we are back to, this is now pretty much exactly as a stock 1 chip would be. There's not much difference. So let's open up the other one and let's try and get a working ASIC first so we know we're dealing with a good ASIC. Go. Where can I put him? In there. That's it. I'll get the desk a bit. He goes there, he goes down there. Right, so clean this mess as well before it starts getting out of hand. So either we've got too bad ASICs or we've got some form of fault somewhere. It's not the work RAM because we've swapped it. It's not the video RAM because that wouldn't stop anything. You can boot without video RAM, so it's never going to stop boot. I can only see it being the ASIC, unless, like I say, I've messed up a pin. I can't see it being anything but just bad luck on these ASICs. So let's just strip this down anyway. My only working game gear. If this is a 2 ASIC, then we're pretty much just going to be swapping ASICs all day until this thing starts working. What do we think? 1 ASIC or not? Ah, 2 ASIC. You might as well just stay back together then. So we're just going to be swapping ASICs. This is, see, I wouldn't mind this on a production one. But with this being a prototype board, I don't think it's going to survive multiple constant swaps of that ASIC. Yeah, this is the 1 ASIC prototype, but at the minute we can't get it working. So I was trying to find an actual keep them batteries. I was trying to find an actual working 1 ASIC, but unfortunately, the only working game gear I've got fully working is a 2 ASIC. So he's out of the question. What do we do? Like I say, I don't know whether I've got any more game gears anywhere else. I don't think I have. Looking for a hidden game gear or one that might be working. No, this is annoying. As it may be worth looking at the schematic. The ASIC's the application specific integrated circuit, I believe they're called. Basically just a chip that's custom for this specific board. So this is the Game Gear's ASIC. This is like the thing that makes the Game Gear what it is. I could do with a known working Game Gear, so when we put this on our board, we could actually know if we've done this right. I'll tell you what, I don't think it's going to help. We've got the trademark pin here, so you can bypass it. I can't remember whether I set this up to be with that blob it doesn't do it, or without it does. I can't remember, but this might then show us the blue screen, like the Sega blue screen. Yeah, nothing. Well, it won't, because the thing is, what's throwing me off here is, are we still not getting VSync on this one? Are we getting the exact same issue? Because, in fact, can anyone remember if the 1 ASIC shows the blue screen without a game? Oh, hang on, there's a problem there. This clean screen's not working. Why has this stopped working? This was working. Yes, this is. That's a bit concerning. This. Have we just got dirty 5 volts? Can't have. Well, could have, but another thought at the minute. I'm just wondering if the 5 volt isn't that clean, because this is this wasn't coming out of wasn't loading the clean screen code, which is normally a sign you've got a dirty rail. Yeah, not too bad. I mean, obviously it's just the USB, so it's not super clean, but No, that's a shame. That was weird though that it didn't boost. Nope, not that. Oh yes, that's. I completely ignored what I said I was checking for. We were going to check if this is missing VSync as well, because if this is acting exactly the same, I'm going to start suspecting something's wrong with the pinout, or something's not right. Because two ASICs to have the same fault would be strange, and it looks like it's got the same fault. So I do think I've got a feeling we've got something wrong on the pins. That's all I can think. There's highly unlikely. Well, I don't know. We haven't worked on enough yet to know, but it's unlikely to be the same fault twice. Like the exact same fault, but it can be. You've seen the VDP failures on the 2 ASIC. It's always the same fault. So if we pull this up, we have the clock as normal. We have obviously 5 volts, which we know of. We've got. Why not just pull it up this way so I can actually see on screen at the same time? Where are the data pins? Where are the data? Oh yeah, in front. This seems a bit blurry. Let me just try and pull focus. There we go. A little bit of extra sharpness. So we have D1 here, just doing nothing at all. No data. Data 2 is doing something. Data 3 is 1 pulse. So where have we got? D0 is pulsing. D1 is not. D2 is pulsing. D3 is not. Obviously that's not the same pin. There's an interesting thing. VSync. That was almost like it was trying to pulse over on nanoseconds. I think that's just noise. So you can almost see a trigger. Let's put a filter on. Now there's something. Huh, look at that. That is the VSync, but it's pulled low. So I think we're dealing with a faulty board. I think this tracers are slightly bad, or is VSync, is that meant to have a pull up on it? But you've got VSync there. I don't know how much that's going to help us, because let's just unplug this. Okay. So the clean screen is pulling VSync low. Why? But that doesn't help us with the fact nothing's loading, but it's also, that is a problem in itself. So yeah, we've got the audio thing on, it's not loading. Then this is a known working clean screen, so why is connecting that up pulsing that low? So something's wrong there. Yeah, that needs him. I'm gonna have to make notes. There'll be a few things I'll have to investigate here. I don't think it's going to be a one issue. So VSync pulled low with clean screen connected. So I need to double check the pins on that are. Where's my mouse gone again? Pins on that are correct. But without the clean screen, we should be obviously looking for then game load. Let's have a look at IO request on reset. Interesting. So that's like different than if we had a game in. So it's obviously not loading game. Let's try again. IO request. See, and now that's completely different. Completely different behavior. There's definitely something not right about this. The problem is we could also be dealing with these being prototypes and all these traces, there might well be shorts on the board as well. So it's like, I don't like the fact that plugging this in pulls that signal low. It shouldn't. Makes no sense. So that's a concern. Do we put the ASIC on another prototype? We've got 4. Do we see, we might be dealing with just a bad PCB. It's certainly possible with, say, the prototypes. That's the whole point. So it's either ASIC swap, I think, or try another board, because that should not be happening where it pulls the VSync low. There's no reason for it to do that. Because I can't see that we've had 2 ASICs operate the same. So the exact same fault. VSync not pulsing. HSync pulsing, data pins have got something on. We've got identical behavior, so it's almost definitely not going to be the ASICs at this point. I think we've got something going on. Let me just focus on this connector. There. And then I want to double check I haven't messed up the connector pins. So the solder on there is okay. Right, so what do we get? Another interesting thing will be, what's the resistance to ground on VSync? The 50-60 Hertz pin, that's just because it's not soldered down. These just bend up. Because they're only soldered on these 3 points, they're not soldered on the cage. They naturally can you can bend them up if you tried, like a little bit, because they have a hole in the board, these holes here. So they are secure in one way, but they're also not super secure. So when I moved it, I just thought it was loose, but that is normal, like the amount. Nice, glad you got the clean RGB working. I think we've got the new batch coming in a few days. I think we ran out the other day. So I just need to meow it, give me a second. Right, resistance to ground on VSync. Just out of curiosity, we can see if it's different than another board. Nope, so that's got high resistance. So why would it pull it low? That's strange. And where is DW? It was down this side, wasn't it? So DW was down here. Where's this mouse? Just want to check we've got a good connection. Visually, it's in line with 1, 2, 3, 4, 5, 6, 7 pins up. It's in line with that. So let's just do a quick check that continuity from here to, we don't really need to count, but somewhere around here. Yeah, so that is a strange one. That's, why is VSync syncing low? Let me just check the schematic. See if there's any pull-ups on DW. Anything that would give us a clue as to why that syncs. Where's it going? DW. Oh, it goes to another page. Of course it does. Pin 50. Yep, it is pin 50. So pin 50 goes straight to LCD connector pin. DW. No, there's no pull-ups. That's concerning, that is. Unless that's just a common failure. So that's a mystery. But do we try another board? So I think it's worth just trying another board, see if we get similar symptoms. And we've got 2 left in here. And we have an ASIC, but what we'll do is rob another ASIC anyway, so we're playing with yet another new one. That's out the way, man. There. All them seem okay. So I think the only issue we had was one of them had the just one capacitor probably knocked off in the bag. Yeah, that all seems fine. Right, and I guess we just pick this one. Go for another one. We got that. We need now another game gear. So let me just go grab another game gear. And which one are we picking? Top or bottom again? We have top one from Japan, bottom one from Taiwan, so back to front this time. What do we think we're going to have a look with? The edge buster, you want to make sure you make the traces really, really short. They have to go into the PPU of the SNES really close to work properly. And then obviously flick the switches. We're going Japan then, let's give this a go. And this one hopefully will be just because this board is that rotten. Look at all the blue. So this board likely would have worked, it's just got that much trace rot. So let's see if we get more luck with this. And then I think if this one doesn't work, I'll probably sit and study the schematic, which is just boring. You just sit there for hours and I'll go through every single pin one at a time. I've done that already when obviously I made the board, but you never know if I'm like, put like a address data 5 and 6 back to front or something like that stops it booting. But I'm more concerned about that VSync dropping. That's a very strange behaviour. Unless this, it also is a chance that clean screen is, even though it works on the 2 ASIC, maybe just slightly loads down the VSync a little bit, but we'll see. Rinse that one off, and then turn around, and then I'll just now do this again under the scope so we get it right. If you go to the wiki, retro6.wiki, and go to the SNES Clean RGB install guide, it shows you an exact position to place the edge buster, which is underneath the board, tapping into the vias of the transistors, and that's how you get the shortest possible wires. But yeah, if you have a long wire, you're not going to do anything because it's all about the fact it's got really short wires because it's injecting current back into the PPU to prevent the slow transitions between the changes in colour. That's how it works. So you've really got to have the shortest possible wires. It's like key to how it works. Alright, that's good enough. I think you can watch that. It's fell into position there, so should be able to show you guys this being done. Probably like that. Move them over gently. There we go. I'm just going to like cool down, push down on the chip. I don't want to nudge it. Wait for it solidifying a bit. There we go, those pins have solidified. So push back down, one more warm up. In case any of them legs are slightly in the air, otherwise they won't make contact. And then don't let me forget to put a crystal on as well. That's right, so now we have 2 prototype boards set up. So if we get the same behaviour on VSync, then we can almost be guaranteed at this point it's not the ASICs. Or that could just be how, like maybe a really common failure of the ASIC is that that's what happens on like the VSync. But it would definitely help if I had a known working one ASIC, because that's going to make this job 10 times easier to be confident we don't have an issue with the ASICs. But at the minute we don't have that. Let me just clean that up heavily. Let's have one last look under the scope. For good soldering, basically. Yeah, solid. Yeah, so as soon as you practice on these a bit, start getting better at them. Now I've done a couple. Yep, so even though they're slightly out of position, they're soldered fine. No, that all looks good. So let's just see if we get any difference on this one. No difference. So we've definitely got an issue on the board somewhere. So let's just see if this behaves the same. So we've got VSync, HSync, same again, nothing on data 3. Well, different this time, nothing on data 2. So I think we really need to find a working game gear before we can carry on with this one. There's too many unknowns at the minute. I'll look at the schematic and see if I can figure out if there's any obvious mistakes with pinouts. Other than that, I think we need to get a working ASIC here, so we can put something on we know works, and then we can diagnose from there. But at the minute, we could be dealing with just a bunch of dead ASICs. I've literally got a tub full of consoles that people couldn't fix, so they might well just literally be dead ASICs, and tons of them. So I'll try and find one. If I have to buy one or get a working original up and running, I'll do that. And then once I've got a working ASIC, I'll jump back on and we'll carry on, I think, diagnosing this. But it might just be the ASIC. So until I get to that stage, we're just getting up swapping chips constantly here and not being sure of what's going on. Yeah, this is a full-time job for multiple people. We do this every day. Actually, let's just check that VSync, see if that drops as well before we finish up. USB, let's just see what I want to see of that VSync. If it's, well, we'll know from, we don't even need the scope. We can see how that's not booting again. There's something strange going on because we don't get any boot light, the orange boot light, and no, we've got the power but no orange boot. So that's not normal. It's like the intermittent power up of this is very strange. There we go, now that power's up. And the exact same issue. So something's going on with that VSync that's strange. Like something seems quite off here. Like why is that dropping VSync when we connect this ribbon? Just doesn't make sense. Remaking the ASICs is basically just emulation at that point, which people have done. They've cloned over, but making an actual package the same or a chip, that basically turns it into emulation. So it's like we could do, but then the ASIC's the key to the game gear. It's like the heart of it. So if you're going to swap that, there's not much point. You might as well make a fully new emulated version, which in itself is its own thing. Right, I'm going to go off and try and get a working Game Gear, like an original, so we know it's working. And then once I've got one, I'll probably jump back on later today. We might just be dealing with bad ASIC, but I've got a suspicion there's going to be something wired wrong on this board or something missing. I think, if anything, it's going to be like an address or data pin backwards or something as simple as that. So I'll catch you guys later in the day.